All right, so your last rule, and your happy birthday, Dan.
Are you 18 today?
And your last rule is really more of a strategy. And so what I need to do is I need to take a simple function and solve it a way we know how. And then I'm going to use that same simple function and solve it a much harder way. And you're going to say, why would you solve it that way if you could do it that simpler way? And what I'm trying to do is show you that there are two ways that are going to get the same result, and that if we use the second way, that's going to be something that we can use on functions that aren't easy down the road. So you understand, like, how I'm approaching it?
By down the road, you mean not in this chapter?
No, I mean, like, tonight for homework. Actually, no. It's not a rule like a box rule. It's actually a strategy. So I would actually say make sure you pay attention. If you're going to write something down, definitely write when we do the second strategy down, but you might want to write the first strategy down as well. The first strategy is something that we've done before, so if you don't want to write the first strategy, that's fine. But the second strategy is going to be important. I'll let you know when that happens. So I'm going to take this function, x squared plus y squared equals 25. And you actually probably know that function from Algebra 2.
Circle?
It's a circle. It's a circle with radius 5 centered at 0, 0. Okay, so you can actually picture this. Now, I'm saying it, but I'm actually sort of saying it wrong. Picture this function. It's not really a function, though, is it? No, it's like a relation. All right. And I can ask you for, like, what's the slope at x equals 3? Okay, so like find y prime at 3. Now, hold on to that for a second. If I had to do this problem right now, I probably would try to solve for x, solve for y. How'd I do? So far, so good?
You get plus minus.
I do. That's what I was waiting for. Okay, so I need a plus and minus, because plus is going to give me the upper half of the circle, and minus is going to give me the bottom half. And you could graph that on your calculator, and you'd have to make sure you do both branches of that. It's almost like a, no, it's not, never mind. All right, so this is actually two problems. We have to take the derivative of the plus square root and take the derivative of the negative square root. I'm going to rewrite it as this. No, that's not rewriting it. You cannot. Do not even try. I mean, you're going to get 5 minus x, 5 plus x. So you can factor it like that if you want, but don't dare tell me that it's 5 minus x, because I'll freak out. Is that okay? Like, some people like to take the square root of 25 and the square root of x, and that would be bad algebra. That's not what you were thinking. Good. I'm glad. Yeah, you could do the square root of, it's a difference of squares, right? 5 minus x, 5 plus x. It actually isn't going to make anything much easier for us. Okay, so the derivative, plus or minus 1/2, raised to the, but don't forget to chain on the negative 2x, that's the chain. Okay, so this actually tells us, let's see, if I multiply a plus minus by a minus, that's just going to be a plus minus, right? So it's going to stay plus minus 2x over 2.
Oh, no, he's
I'm rewriting it. Yeah. Right, 2x is in the numerator, 1/2, that 2 is in the denominator, and this is, since it's to the negative 1/2. Is that okay? Did I fake anyone out with algebra? Is that all right? All right, I'm actually going to get rid of the 2's. So that's what I get. Is that okay? So if I want the derivative at 3, this would tell me that the derivative at 3 is equal to plus or minus 3 over the square root of 25 minus 9. What's that? Plus or minus 3/4. So that actually tells me, look, 1, 2, 3, the slope here is negative 3/4, right? Or the slope down here is positive 3/4. So does it make sense that the derivative at 3, there should be two answers? Okay. We could have done that as long as we knew the chain rule and the power rule, we could have done that before. So do you agree it's a problem that we could have done before? True?
When you multiply it, and you just said it real quick, that when you multiply a plus and minus times a minus, it's still plus or minus.
Well, all right, fine, Drew. Here's what I'll do for you. Is that all right? Is that okay? I did say it fast. You're right. So basically, if we multiply it, we're going to just get a minus plus instead of a plus minus. So that's the way that we could have done it. I'm going to show you a new way that's going to feel funny at first. Like, not ha-ha funny, but like, oh, that's weird. Yeah. So you're all right with that? Yeah. All right, let's do it. So x squared plus y squared equals 25. Now, here's what you have to remember. We're going to do something called implicit differentiation. And implicit differentiation means that we're going to do some information based on what's implied by y. And it's important to remember that x is a variable and y is a function. Y is not a variable. Y is a function or a relation that's implied by this equation. As a matter of fact, what's the equation that this equation implies about y? Y equals plus or minus the square root of 25 minus x squared. But we're not going to actually solve for y. We're just going to keep in mind that y is a function. So I'm going to take the derivative of everything here. I'm going to take the derivative of x squared, and I'm going to get 2x. I'm going to take the derivative, I'm going to hop over to the other side because it's easier, the derivative of 25 and get 0, nothing. All right, now, if y was a variable and I took the derivative, I would get 2y. But y is not a variable. Y is like a function. I don't know what the function is, but y is like, it's almost like y is thinking, I'm smiley face squared.
So we're just still get like 2y.
All right, so what's the derivative of smiley face squared? Yeah, I have to remember that there's a chain. Now look, the chain of y might be 1, but it might be something more complicated. As a matter of fact, remember when we did the problem up here? The chain of y was negative 2x. So here's how I'm going to write it. I'm going to write it as 2y times the chain, which is y prime. And if you just remember that y is a function, and that you always need to chain on its derivative, then we can actually do something called implicit differentiation. We get 2y times y prime is equal to negative 2x, and y prime is equal to negative x over y. So this actually tells us two things. We can look at it, I guess, two ways. The first way we can look at it is, if we go back to this circle, 3 comma what? If it's x squared plus y squared equals 25, what's the y coordinate? Do you agree? 4. And this would be 3 comma negative 4. So go back down to the implicit differentiation. This says the derivative is equal to the negative x over the y coordinate. Negative 3 over 4. Right? The x coordinate's 3, the y coordinate's 4. Or, whoops, I should say or, not equal to. Or negative 3 over negative 4, which is 3/4. So do you see how we got the same answer with implicit differentiation?
How could you get that answer if you didn't know the original derivative?
Yeah.
If you didn't know we didn't know the original derivative at all.
But we did.
We didn't.
But I'm confused because you
So
said,
wait,
it's negative x over y prime. How do you know what y prime is?
That's what I'm trying to find. I'm solving for that. Right? I want to know what the derivative is. Well, the derivative in this case is x over y, negative x over y.
Yeah, I'm sorry. What I mean is how could you figure that out without knowing what y is?
Oh, well, you bring up the downfall of implicit differentiation. The downfall of implicit differentiation is you actually, to find the derivative 9 out of 10 times, you need not just the x-coordinate, but you need the y-coordinate. Now here's what I'll tell you. How hard was it to find a y-coordinate? It wasn't hard at all, right? Now, you're going to see situations where it might be harder to find the y-coordinate, and we might actually give it to you. We might actually say, find the slope at this point, 3, 4, instead of saying at x equals 3. So David's comment's a very valid one, and one that I was hoping someone would say, but wait. Well, this is what I was hoping someone was going to say. Wow, implicit differentiation was a lot easier than doing the chain rule. I actually think that we only did like 1 or 2 steps, and it was pretty straightforward. I'm not saying conceptually it was easy, but it was pretty easy. But the downside, the trade-off is you need an x and a y coordinate. You have to go do the work to find the y coordinate. All right. I'd like to point out just another way of looking at this. This says y prime equals negative x over y. Well, remember up here we actually solved for y. Y is equal to the square root plus or minus the square root of 25 minus x squared. So we could also say negative x over plus or minus the square root of 25 minus x squared. Since we knew what y is, we could solve for it and plug it in. Hey, look at that. When we did it the first way, we got that. Doesn't that look just like that? So here's what I want you to do. I want you to buy into the fact that implicit differentiation works. I want to do like 4 or 5 more examples with it, but I want you to believe me that it works. It gets us the same answer as if we didn't do implicit differentiation.
Does this only work with circle, or does it work with...
No, it actually works with any implied function or relation where it's not easy to solve, readily easy to solve for y. All right, and we can take a look at like 3 or 4 more examples. Do you believe me that it works? You don't like it because we haven't done a bunch of them. Okay. It shouldn't, right? Because why would you do it if you could just solve the first one for y? I agree. All right, so we should do a few examples. And can I tell you this? This is going to be number 10 on the gateway.
Specifically the problem you're about to do? Or
No.
No, like this type of
All right.
Hey, it's worth asking.
Let's do it.
It's awesome.
All right. So here's a problem where implicit differentiation, because we're taking the derivative implicitly. Okay. Here's a problem where you might be inclined to solve for y, and you probably could. Do you see how maybe you could solve for y? Just out of curiosity, if you had to solve for y, what first step would be? And then I heard Morgan say, whoops. So you could divide and you see it would be a quotient rule? Okay. All right.
I have a question.
Yeah.
On the gateway, if it's like something where we're able to solve for y and we use
Yeah, it's fine.
Okay.
No, so the gateway, like, whatever you can do, you can do. Like, if you come up with something super clever and get the right answer, that's awesome. Okay? All right. We're going to try implicit differentiation.
Oh my god.
We're going to do this implicitly. All right, so I'll tell you what. I'm going to do the derivative of x, that's 1. And I'm going to do the derivative of 5, that's 0. I now need to know what the derivative of x times y is and what the derivative of y is. I'll start with y. What's the derivative of y if it were a variable? You'd tell me it's 1, but it's a function. So Dan?
Just y prime.
Okay, so the derivative of y is y prime because it's a function. We treat it differently than we treat x. Now, x times y is a handful. Someone,
Would it be like x, y, or plus y?
What are you thinking? What rule are you thinking?
Like,
Product rule. It's definitely the product rule. So let's talk about how we would do the product rule for x times y. First, times the derivative of the second plus the second times the derivative of the first. Okay, good. All right, so now I have this mess, and I think I just need to do a little bit of algebra. I get xy prime plus y prime is equal to negative y minus 1. Gesundheit. I subtracted y and 1 from both sides. And now I get y prime is equal to negative y minus 1 over x plus 1. Okay. We good, or should we go back? I did a little too fast. Right. So the question was find the derivative of y. So this is the derivative of y. That's the answer. Now the trade-off for this, the problem is if you actually had to find the slope at a point, you would need an x and a y coordinate. If we did the quotient rule here, golly. Right? You could do low d high minus high d low all over low squared, and you would not need an x or y coordinate. Can we do another? Do you want to ask a question?
So would the answer be the same?
All right. So let's see. Low d high minus high d low all over low squared. So I'm going to get, let's see, negative x minus 1 minus 5 plus x all over x plus 1 squared. The x's cancel, is that true? And I get negative 6 over x plus 1 quantity squared. All right, so it doesn't look like it now, but what if we actually plugged this in for y?
That would be awful.
So will you believe me that we could get them to look the same? Okay, we can get them to look the same. It might take a little work to get them to look the same. And Alicia, another part of it is there might, well, actually, let's do it. Let's do, is that true? Huh. That's interesting. Oh, that's great. Good. Let's do, yep. All right, so here's a problem where I don't care what you do, you're not going to solve this for y. Okay? So here's an example where no matter what you try to do algebraically, it's not going to get any better than this. So you have to use implicit differentiation. You don't have a choice. I'll do the right-hand side. You want to talk to me? All right. Why don't you you can take one of the two pieces. Which piece do you want, Morgan? Second piece. All right. 3y. Perfect. Right? So it would be, if y was like a smiley face, it would be 3 smiley face squared chain on the derivative of y. Perfect. All right. Morgan, you want to call on someone for the first piece? First. Derivative of the second. Derivative of the first times the second. Perfect. So now I have an equation that involves derivatives, and now I can start solving. My strategy, I'm going to keep everything with a y prime on the left-hand side, and I'm going to subtract 2xy. Next step. Factor out the y prime.
You said keep everything. Okay.
With a y prime on one side, right? And now finally, after I factor out the y prime, I can divide. So, go ahead.
So, you know how before we didn't have to, like, get rid of anything, like, simplify? Or this we do?
So, I guess, yes, the answer is yes, because what we're trying to do is we're trying to solve for the derivative. So, this equation up here isn't this is like a relation that involves the derivative. So now we need to collect and solve for y prime. I would say this, Katie, if once you solve for y prime, if there's something like a difference of squares or you can factor or reduce, you don't have to do that. Like, you don't have to simplify the right-hand side after you solve for y prime, but you need to get y prime equals, okay? And it's going to be number 10 on the gateway. This is the first problem that we've done that you actually couldn't solve for y in the first place, and you need to do implicit differentiation. I think there are also a bunch of functions or relations where implicit differentiation makes it easier, and I would say probably number 10 is going to be one where you have to do it. I don't think you're going to have a choice. You can try to avoid it. And I find implicit differentiation is one of those things where some students actually, like, once they see it, they find very intuitive and it's like not a problem, and they walk into the gateway knowing they're going to get number 10 correct. There are other students who are totally skeptical and don't really buy into the implicit differentiation and never really learn how to do it, and they go in knowing that they're going to get number 10 wrong. I would encourage you to get it right, because then it's one less problem that you need to worry about getting right. You can check that off your list out of the 8 that you're going to get right. Let's do maybe one more. We could probably solve that. We could definitely solve that for y. But let's do implicit differentiation because we're having fun with it. All right, square root of x. Katie Rayner, you want to take a shot at square root of x?
Okay. So,
Perfect. All right, so the derivative of root x is 1/2 x to the negative 1/2. Julie, you want to take a shot at 5 root y? If you want to treat 5 as a function, you need to do the product rule. First times the derivative of the second plus the second times the derivative of the first. Or you can just treat 5 like a constant, but you can't say the derivative of 5 is 0, and so 0 times anything is going to be 0. So you want to try it?
Yeah. So 5 times 1 plus
Not yet. Y is not a variable. If it were, you'd be absolutely... Yep. Perfect. And now you're going to say plus something times 0? Yeah, so I'm just not going to write it. All right? So here, the chain is y prime. And now we can solve for y, I think. The 1/2s go, right? To get rid of y to the negative 1/2, multiply by y to the 1/2 on both sides. So I think we get 1/5 y to the 1/2 times x to the negative 1/2.
Wait, how do you get the 1/5?
5? Right? Don't you want the 5 on the other side?
Wait. Oh, right.
Okay. And your book would probably write it as root y over 5 root x would be my guess. Maybe how they would write the answer. Lots of quiet today. I don't know if that's because you like it or don't like it.